Okay. I have not tried this one at all. Going straight cold turkey on this one. So you'll forgive me if I go back and forth on it. I've mentioned in class a couple nights ago. I don't know if everybody got the word on this one, but I don't. This I'm not requiring right here. This part right here. Don't worry. I will count that as being done for everybody. Don't worry about it. Because to be honest, I'm not really sure what they're talking about. But unless, because it's not series or parallel to me, it's a Kirchhoff's. So anyway, maybe there's something I'm missing because it is new and all that. The book we're using, although it's got some similarities to it. So they give us a bunch of letters, and they even tell us specifically what loops we have to use. So indicate that, okay, so do the native, okay, so let's give this a shot. So this loop. That one, I assume in that order. They've already given us the directions, at least now here's what I don't know. I don't know if the directions they've given us are correct or not. I guess we'll find out. So starting at A and proceeding to B. So we know we're going to start with 0. I'll try to write small here. I go with the current for resistor 2. So that's going to be a drop of -3I2. Then we go up 18 volts when we cross here. Let's see, B, C, D, so then we're going with the current again, so we have another drop, that's -0.5 I1. And then E, F, so we're going through against the current here, so that'll be a rise, and that will be, oh, interesting, they call this I2, don't they? Okay, that's one of the things that makes this problem interesting. All right, so hold on. So I'm going to alter this and make that, so that is so there's multiple resistors in one loop, and they decide to call that I2. So, okay, we're going to adjust that, make that I2. I'm glad I caught that. And then we're going to go against the current in resistor 3, so that will be plus 2I3. And when we get to, so what do they call, oh, I got this. Okay, so first the little r's, my apologies. The little r's are the internal resistance inside the battery, of course. Okay, got it. So we still have to count them, though. So we're going to go up 0.5 times I3. So I'll have to wrap this around, plus 0.5 I3. And then we go down this one, so that's going to be a drop of 45. And that brings us back to the beginning. So we've gone all the way around like so. Now, cleaning that up a little bit, I got 0 equals, let's see, -3.5 I2 when I combine this and this. Plus 18 volts, and then positive 2.5 I3, and minus 45 volts. So let's do this. Let's put the constants on the left. That's going to be a -18 and a -45. We'll combine those, and then whatever's left over, we will put on the left-hand side. So come with positive. So it'll be 27 equals, and we'll write it this way: 2.5 I3 minus 3.5 I2. All right, so there's one equation. So there's only 2 currents here. So we only need 2 equations because there'll be 2 unknowns, the 2 currents. And the next one is AE. That? I can't tell what that is. There we go. AEF. So I'm going down. Okay, so we're going to do, the next one's going to be, we'll use this color. So we're going to go like so for this next one. Starting at A, we go through resistor 1 upstream, so that's going to be 0. So this is for the loop A, E, F, G, H, and back to A. 0 is going to equal positive 5.2 I. Oh, I lied. There is another current. There's I1, so we'll figure this out. I1. Going around this way, another up to I3, up 0.5 I3, down 45, and that's it. Alright, so we're going to clean this up. 45 is coming over, so we'll have 45 equals 5.2 I1 plus 2.5 I3. So I have this equation, this equation, and I have this equation. I'm thinking, they tell me to use a junction rule? Am I allowed to use a junction rule? So I have those two loops. I got 3 variables though, so I'm going to go to a junction rule on this one. And I'm going to go with, let's go with A, junction A. So at junction A, I have 1 in and 2 and 3 out. So that means junction at A, I got I1 is equal to I2 plus I3. And I guess I'll replace I1 in this equation here with this. That should do it. Get me 2 and 3 by themselves. Yep. So I'll have 45 equals 5.2 times I2 plus I3 plus 2.5 I3. Let's see, 45 equals 5.2 I2 plus 5.2 I3 plus 2.5 I3. And that's going to give me 45 equals 5.2 I2 and 7.7 I3. I'm going to use this equation in conjunction with, almost there, in conjunction with this equation. 27, 2.5 I3. 27 equals 2.5 I3 minus 3.5 I2. I got to clean some things up there, but that's what we're going to use. So let's rewrite this. Let's put them like this. So 45 equals 5.2 I2 plus 7.7 I3. Underneath of it, I'm going to write 27 equals negative 3.5 I2 plus 2.5 I3. That way the 3's and the 2's line up. I'm going to multiply everything in this top equation by 3.5. And I'm going to multiply everything in the bottom equation by 5.2, taking advantage of the already positive and negative nature of those two numbers. That should get rid of I2. And just like that, bam, there it is. So hopefully, let's see if this works out. These will go away, and I'll get, let's see, 13 to the right side this time. 13 plus 26.95. So that gives me 39.95. I3 is equal to 157.5 plus 140.4 equal to 297.9. Divide both sides by the 39 and change. I get 7.457. I'll take it. They encourage us to take out a bunch of decimal places intermediately, so 45682 there. Amps. Now, I gotta go plug stuff back in. Might as well plug it into the closest one I can see, which is this one. So I'm gonna have over here, we'll do this in green, so I'm gonna do 27 equals negative 3.5 I2 plus 2.5 times 7.4562. So I get I2 as being negative 2.388. Interesting. So their guess or their indication for the direction of the current must have been the other way. Must have been wrong. We'll see. And then I know that 2 and 3 add up to 1, I believe. So I keep the negative for this. So I keep the, because when I do this, mathematically, I know this means the current's going the wrong way, but I won't say that until my final answer. I won't make it positive and indicate that I have to keep that negative mathematically. So we're going to do that plus 7.45682 and get a current for I1 of 5.0688 amps. Let's just double check to see if we're even remotely in the right ballpark. I don't even know. So we'll find out. It'll be embarrassing if I'm not. I don't have the answers to this one sitting here. That's right. Hold on. First of all, we got to do that. All right. So let me see. Hold on. I can get these answers. They're here somewhere, I think. Here. Not that one. But this one. And I think these 3, 5.2, 2.0, is that the ones we just used? Is this the one we used? Yes. Why do I have... Oh, because I added that. Okay, so we're good. I think, let's go look, that this is right. So let me go to the assignment previewer. So this is saying that I should have 5.07 to, I think, 7.46. Here, we'll do this. Alright, so it looks like we're in decent shape here. So that they, in fact, did have I2 incorrect. So they want you to give the negative to indicate that, but what I really do is just point out that the stupid I2 is actually going counterclockwise, not clockwise. Okay, I think that's that.